Hello everybody and welcome to this lesson. Today we are going to be verifying trigonometric identities. Okay, our objective for today after this lesson will be able to verify trigonometric identities and determine if equations are identities. Okay, so those are the two things that we're working with today, and we have a few different techniques and methods, so let's go ahead and get started to see which ones we use and when. Okay, so the concept for today, all right, we're really working with proofs, okay? We guys have done this before. We're really just proving or showing that both sides of an equation are equal when we do this, okay? And we're going to rely really heavily on previous identities from previous lessons, okay? Those identities include our reciprocal and quotient identities, okay, our Pythagorean identities, our cofunction identities, and our odd and even identities. So if you don't understand those identities, make sure you go back and have a look. Make sure you completely understand what these identities mean, because that's what we're going to be using as our basis for today. Okay? So let's jump into an example right away. Okay? If we're asked to verify that the secant squared of theta times the cotangent squared of theta minus 1 is equal to the cotangent squared of theta. Okay? We're given this equation. First thing we want to do is we want to take a look at which side is more complicated. Okay? And we're going to work with that side. We can't do a whole lot here with my cotangent squared theta, but I can do quite a bit with my secant squared theta, cotangent squared theta minus 1. Okay, so our first technique we're going to do here, we're going to rewrite everything in terms of sine and cosine. Okay, so secant squared theta we can rewrite as 1 over cosine squared theta. Okay, and then cotangent squared theta I can rewrite as cosine squared theta over sine squared theta. And we're multiplying here. Okay, and then we have our minus 1. And I'm just going to work with this side of my equation, okay? I'm not going to touch the right-hand side of the equation at all, okay? Just working with this one side here. Okay, I can see that since we're multiplying here, my cosine squareds cancel out, and I'm left with 1 over sine squared theta minus 1, okay? Well, this is going to be equal to 1 over sine squared of theta. I can actually rewrite as cosecant squared theta. Cosecant squared theta minus 1. Okay, now from here we're going to rely on our Pythagorean identity. Okay, we're going to rely on this one here that says that cotangent squared theta plus 1 is equal to cosecant squared theta. So if I go ahead and I solve this for cotangent squared theta, it's going to be equal to cosecant squared theta minus 1, right? We're just going to subtract 1 from each side. And would you look at that, I have cosecant squared theta minus 1 right here. So this is going to be equal to cotangent squared theta, which is what is the right-hand side of my equation. So that checks out. This equation is an identity, okay? So that's kind of the basic process here that we're working with. Okay, let's take a look at a few more examples. If I'm asked to verify that the cosine of alpha over 1 plus sine of alpha plus cosine alpha over 1 minus sine of alpha is equal to 2 secant alpha, okay? Again, I'm going to identify which side is more complicated, okay? And we're going to attack that one first. Okay, so our left-hand side is our more complicated side, so we're going to work with this one over here, okay? And our technique that we're going to use here, we're going to combine our fractions, okay? So in order for us to do that for our left-hand side, we need to come up with our LCD. And we can see that our LCD here is going to be 1 plus sine alpha times 1 minus sine alpha, okay? So I'm just going to rewrite this. I'm going to say, okay, what is this first term missing in its denominator from the LCD? Well, it's missing the 1 minus sine alpha. So I need to multiply cosine alpha times 1 minus sine alpha divided by this 1 plus sine alpha times 1 minus sine alpha, okay? Okay, so that's what I'm multiplying my first term, and then my second term I'm going to multiply by, so I've got cosine of alpha, going to multiply by my 1 plus sine of alpha. Okay, which is going to give me 1 minus sine alpha times 1 plus sine alpha for that term, okay? So what I can see here is that I actually have this a plus b times a minus b, okay? We've seen this before. Okay, so this foils into a squared minus b squared when I'm looking at my b squared, looking at just my denominators, right? Okay, so I'm going to rewrite this as cosine of alpha times 1 minus sine alpha plus cosine alpha times 1 plus sine alpha. Okay, I'm going to combine these, right, under the same fraction, or over the same fraction, and I'm going to do this foiling method here, okay? So I'm going to have my denominator is going to simplify to 1, since a is 1, and then my b is going to be minus sine squared alpha. Minus sine squared alpha there, okay? Okay, now we can take a look and we can say, well, what can I factor out of the top here? Okay, what can I factor out of the top? I can factor this cosine of alpha, right? So I'm going to have cosine alpha times 1 minus sine alpha plus 1 plus sine alpha. Okay, that's what my whole numerator is going to be. All over this 1 minus sine squared alpha. Okay? And we can see here I'm going to have 1 plus 1, and I'm going to have sine alpha minus sine alpha, or minus sine alpha plus sine alpha. So my sine alphas are actually going to cancel out, and I'm going to be left with just 2 cosine on the top. 2 cosine alpha over 1 minus sine alpha, sine squared alpha, sorry. Okay, and then we can use our Pythagorean identity that says, sine squared alpha plus cosine squared alpha is equal to 1. Okay, so when we solve that for cosine squared alpha, we get 1 minus sine squared alpha, which is what we have here in my denominator. So 2 cosine alpha is going to be equal to cosine squared alpha. And that is going to simplify to 2 over cosine alpha, which simplifies to 2 secant alpha, which was exactly what we had on the right-hand side of our equation. So that checks out as an identity. Alrighty. 2 more examples here. So example number 3, we're asked to verify cosine of x times secant squared of x times tangent of x minus cosine x tangent cubed of x is all equal to sine of x. Okay, so again, look at which side is more complicated. Again, we're working with the left side, and now we're going to factor. Okay, so what can I factor out of here? Well, I can factor a cosine of x times times a tangent of x. And in my first term, I'm going to be left with just a secant of x, or secant squared x, rather. Okay, minus, I'm going to have tangent squared x for my second term, okay? And when I do that, okay, we're going to use our Pythagorean ID that says tangent squared of x plus 1 is equal to secant squared of x. So when I solve this for 1, I get secant squared x minus tangent squared x, which is what we have right here. So this is actually going to simplify to just 1. Okay, this whole bracket right here is going to simplify to just 1. And then I'm going to have cosine of x times tangent of x, which is what we factored out earlier. Okay, And we know that we can rewrite tangent of x as sine over cosine. So I'm going to rewrite this as sine of x over cosine of x. And we see that our cosines cancel out, and we're left with just sine of x, which was the right-hand side of our equation, so that checks out. Okay, so our last example here, okay, when we have two sides of our equation that are basically equally complicated, okay, what we're going to do here is we're going to work with both sides individually to try to simplify these. Okay, so first we're going to take a look at this side here, our left-hand side, and we're going to use our Pythagorean ID. Tangent squared of x plus 1 is equal to secant squared of x. Okay, and when we solve for tangent squared of x, I get secant squared x minus 1. Okay, so I'm going to replace this tangent squared of x with secant squared x minus 1. Okay, secant squared x minus 1 all over 1 plus secant of x. Okay, now again, using our difference of squares, okay, I've got a squared minus b squared. That's basically what I have in my numerator here. Okay, so I'm going to go ahead and factor that out into a plus b times a minus b. So that's going to be secant x minus 1 times secant x plus 1 all over this 1 plus secant x. And I know that 1 plus secant x is the same thing as secant of x plus 1, okay, which is what we have here. So those guys are going to cancel. So I'm left with secant of x minus 1, okay? Secant of x minus 1. So now I'm going to take a look. That was this left-hand side here. Okay, this was the left-hand side. So now let's take a look at the right-hand side here. Our right-hand side is a little bit easier, okay? I just can simplify. Let's see, I've got 1 minus cosine of x over cosine of x. Cosine of x, okay? So I'm going to separate this into 1 over cosine x minus cosine x over cosine x, okay? We're allowed to do that here, right? I've got separation by subtraction in my numerator with one denominator, so we're allowed to separate like that. Those two are equal. Okay, so 1 over cosine is just going to be secant. And here we are going to simplify to cosine over x over cosine over x. Sorry, cosine x over cosine x is just 1. So our two sides are equal here, and we have an identity. So that's it for this video. That's it for this lesson. Good luck with your practice.